Hi, everybody. Welcome to today's lecture for data science. I'm going to do the Python notebook lecture style again. So if you want to follow along, please download the slides now. I actually had the impression by now that nobody was using GitHub here. I got a few requests now. So next time, I'm going to make sure that I push the slides before the lecture. For now, they're only linked on the home page in the Google Drive folder. So if you go right now to the data science webpage, then you can see on the schedule, this is where all the lecture slides are linked now, right? And then we're at lecture 7 already. And you can see the link here. And if you click there, this should take you to the Google Drive folder where you can download the slides for today if you want to follow along. So you're going to need this images folder if you want to display some figures that I downloaded and put in there. And then the custom.css you don't really need. This is mainly for me to make the notebook look like slides, so have the font sizes and everything so you can see it properly. If you have the notebooks on your laptops, you don't really need to bother about this file, but you can download it if you want. And you're going to get an error if it's not there, but you can also just delete that cell. And then this is the actual notebook I'm going to use for the lecture today. So just again, if anybody needs to reach me, this is my email right in the beginning. We also have the staff email list that all of you should know by now. If you have time-critical things, it's good to at least CC the staff email as well, because here is where all the TFs see it, Raphael and I see it, and Stephanie sees it too. So if you need a fast reply, you have a way higher chance of somebody seeing it quickly than if you email just one person. Did everybody who wanted to download the slides by now? Does anybody need more time? Wait. Yeah. So I'm just going to talk about this in the meantime. So I got an email from these guys. There's a site at Harvard where you can promote your student projects. So it's the Harvard University IT Student App Spotlight. And you can see they already have the best projects from the visualization class up there. I'm not entirely sure. It seems that it's tailored towards web applications. But if you scrape in the end some cool data and make a homepage of it, or maybe you even use some live Twitter streaming or something for your projects, I think this is a really cool way to promote your projects and to make them known to other people out there. So that link is in the slides if you want to dig it up later. Then homeworks. The solutions are online. And our awesome TFs are working, and we're going to try and have all the grading done by the end of the week so that you can get comments and feedback on the problem assignments. In general, we got a few emails that were very, very last minute. Please, when you think about doing the homeworks, be proactive. It's better if you start early. It's just really, really difficult to get help if it's half an hour before the Dropbox closes. Also, those Dropboxes are not closed manually. They have a timer, right? And they close at midnight. So if you try to submit 5 minutes past midnight, that Dropbox is closed. If you still have late days, so the normal Dropbox closes Thursday at night, right? And then the late day Dropbox opens. So at that point, you can only submit to the Dropbox that is going to deduct one late day. But this is exactly what the late days also are for. So just so you know, like, it's timed, right? Midnight, the door closes, and it's a good idea to try and submit your homeworks a bit earlier. And please, please use the office hours and piazzas. They're out there to help you. And if you have problems, if you think the resources are not enough, right? If you tell, you go to an office hour and you think it's so crowded that you can't get your question answered, anything like that, please, please tell us. Don't tell us half an hour before the homeworks are due. Tell us a few days before so we can say maybe have emergency office hours or something like this. We will really try to accommodate your needs, but we need to know your needs in order to do this. Then homework submission format. I know this was not on the direct homework assignment. If you didn't do it this time, it's not a problem. The TFs will grade your homework. But in general, this makes the life for the TFs much, much easier. So if, not if, but for starting with the next assignment, please create a folder that follows this naming convention, right? Your last name, underscore, your first initial, the homework, and this is a placeholder for the number of the homework. And then you put your IPython notebook and all other files that you think this notebook needs into that folder. Normally, the homeworks are designed in a way that you really should only need to place your IPython notebook in there. Those notebooks should be executed. So just right before you submit, there is a button up there that says Run All Cells. Hit that button, right? So then the TFs can directly see your results. And then you compress this folder here, and that is what you submit to iCites. And this is very convenient for the TFs because they have your name already there. It's one convention for them when they want to grade the homeworks. And if you need extra files, they have everything in one place. So this really, really makes life easier for us. Are there any other logistic questions? Because other way, I'm going to dig into the homework, into the lecture. All good? Okay. So the new homework assignment is actually coming out today. It's not out yet, I think, but it's going to be out sometime later today. And we're going to try and make more comments there. Like, we got a bit of feedback from people that you need more explanations for the problem sets. So the next homework is going to have more commentary before the actual problem sets. So, okay, fun part. We're going to talk today about data scraping. This is really, really powerful knowledge, and it can make your life a lot easier, especially if you're a data scientist. So what is data scraping? Does anybody know? Really? Nobody has ever heard about data scraping? Yeah?
Retrieving data that might be like on a web page or something, and might be structured in a certain way, and scraping it off the page and into some sort of data structure?
Yes, exactly. So you have your data somewhere out on a web page, and you want to access it. Because you're a data scientist, and so you need data to actually analyze and do cool visualizations with, right? And this is the way to get it. And there are several versions. The harder, but also maybe more powerful part is to directly scrape data from websites. This means any websites that you normally surf in everyday life, you can get data out of them, right? And I'm going to talk about how to do that. Then there are some web pages who try to make your life easier. They offer a so-called API. What that means is they offer an interface that you can use to download data. They basically provide the data in a better format for you. And then we're going to do a bit more about singular value decomposition, just how to do it in Python and things, because this is going to be relevant for the homeworks. So if you want to follow along, I'm going to do some API scraping later on, or just downloading. If you want to follow along that part, I also posted this early on Piazza, you need to fill out these forms. So you have, I'm going to show Rotten Tomatoes and Twitter. So if you click on the Rotten Tomatoes link, Let's close this guy. This is how you register for their API. I'm just showing this now because in case you want to do it, you need to register there now. And then they're going to send you an email with the key, which you're going to need later to make the code run. So if you want, you can put your username now in here. So I normally do Vorkeinig. And then you have a display name. And the first name and the last name. It doesn't really matter that much because unless you're planning to make this into a real cool application later, as long as it's just for this class, you can basically put dummies in there. So leave away everything that does not have a red square there because only those fields are required. And you put your email. To confirm that email, password, and repeat the password. And name of your application, you can really do whatever. I'm not sure. I think those names might have to be unique. So maybe do a first-last name combination or something, because if we try to all register with CS109, it might not work. And the URL here also really doesn't matter. So there's always this example.com. That's an actual website. That you can put in there. So just fill something out there. To confirm their terms, and then you can register. Everybody with me? Okay, I notice a problem here. I don't know whether you're checking emails or registering. Who's still registering? Oh, wow, okay. Okay, I think I'm actually going to skip over the Twitter part at the moment because this is going to take even a bit longer. I'm going to see when we come to the Twitter part how much time we have left, and then if there's enough time, you can follow along if you want to. So Python data scraping. Why scrape the web? So it's a really, really vast source of information, right? I mean, come on, it's the internet. You can also automate tasks. The first thing that came to my mind was I still need an apartment, Craigslist, right? Don't have to check it every half hour, write a script. Turns out they don't really like to be scraped. Like from all the forum posts and everything I read, they prefer if you do not do that. The reason maybe is obvious. Like I even read a post from someone who said, I just want to see who's interested in what I'm doing and then email them, right? So you can go in Craigslist, like who's looking for job offers, and then email them, right? Targeted. That is called spam. So we don't do that. You can also just keep up with sites, right? Maybe there are web pages that you check every morning, and you can assemble them into one nice email script for yourself to save time. And it can just be fun. So can you think of examples? What are cool things to scrape, maybe? Think about projects. What are good sources of information out there? What are web pages you look at every day, maybe? What? Stock information, yes. Can have a script that pulls it every day, right? Assembles it, maybe over a month or two, and you have a nice data set to analyze. Other ideas? Yes? Airlines, airline prices. Yes, very good topic. Yes? Sports web pages. Yeah, actually, just briefly saw a Piazza post about sports data. So if anybody's interested, check that out. Yeah? Amazon, yeah. Amazon even, I think, has an API. I'm not sure whether you actually need to pay for that. Have to see. So especially those big web pages, Amazon, Yelp, Netflix used to have an API. They're actually not maintaining that anymore. I think it's going to close soon. But a lot of these very big, popular IMDb web pages are going to make life even simpler for you if you want to scrape data from there. So lots of applications. Here are just two that I found. This is from the New York Times webpage. The New York Times also has an API where you can scrape their articles. And what this guy did is he takes the location of a New York Times article, and then he follows Twitter posts and sees how over time people react to this article and tweet about it. Right? And what you see here in this visualization is all the different locations that all link to the location that this article was about. And then you can see neat things like, I think this is Denmark up here, and apparently Africa doesn't care that much about Denmark, so these things come up. That can be nice to see. You can also look on the project webpage. There's a video that shows this in real time. And then this was one that also combines even machine learning a bit in here. So this is data scraping visualization with machine learning. Twitter sentiments. What these guys did is they scraped Twitter, and then they did a sentiment analysis. How that works is basically you have a database that has a lot of words, and for each of these words, it has a score, how basically happy or not happy that term is. And you can use that to calculate kind of a happiness score for a Twitter tweet. And they did this visualization here. So here are terms like stressed, nervous, tense. And then here people are excited, elated, happy, pleasant. And you can see here the distribution of tweets that are about Grand Canyon. So just ideas what possible projects can look like. And this is something we're going to come to an example from Catherine Jamul that I found online. She has a nice video about data scraping online where she gave a course on, I think, PyCon. And she scraped downtown LA, the happy hours according to her personal preferences. So you can go there and say, like, I like sushi. And then it's going to scrape all the happy hours out there that actually promote sushi. So just word of caution, copyrights and permission, you should care about those. Please be careful and polite when you scrape, right? It's a lot of knowledge. Knowledge is power. Give credit when you take data that somebody spent a lot of time and effort collecting say where you got the data from, right? Care about media law, and then, of course, don't be evil, so no spam, and no overloading sites. If you use an API, they normally force you to respect their loads and their sites, so there will be a time limit on the requests you can send. But if you do this real data scraping, where you scrape from a web page, there's nothing hindering you from pulling and pulling and pulling, right? So please be nice, especially if it's a smaller web page that maybe doesn't expect 10,000 visitors in 10 minutes, then pace your requests. Robots.txt. Has anybody ever heard about this file? This is part of being nice. Can someone explain what it is? Yes?
It tells you how scrapers are allowed to interact with your website?
Yes, exactly. It's a file that contains rules on what you're allowed or not allowed to see on a web page. So it's specified by the website owner, and it's always located at the top level directory of a web server. So this is just this example web page, so you have some URL, and it's literally just the root URL and then robots.txt. And I checked, even Google has one. Robots.txt. There you go. This is what it looks like. And you can see here it specifies a user agent. Star means everybody out there. And then you have disallow and allow for different folders on the server. And before you scrape a site, when you do it in person, it's nice to just check this file and see whether the owner maybe didn't want you to look into that part of the page you really, really wanted to look into. So what does this one do? Just a very simple one. I already said a star means everybody out there. Then this is just Google, right? So what is Google allowed to do? Everything. Yes, Google, please come and index my site. I want to be found by as many people as possible. And all the others? Stay out. Yes. This is the root of the whole directory. So this robots.txt is entirely voluntary, right? So there's nothing that can force a scraper out there to actually look at this file. And this means you can just ignore it if you want to. On the other hand, it even can be a security risk. Why? Yes? I didn't get you entirely acoustic, but I think you got it right. Yeah? Yes, exactly. You basically tell the user out there what shouldn't be allowed. So you're basically saying, all my secrets are in this folder. Please don't look, right? So this is something you can be a bit aware of. So there are up and down sides to using a robots.txt. So scraping with Python. Scraping is all about HTML tags. So the bad news is we need to learn a bit about those. And websites can be fairly ugly, but it's not that hard because we don't need to understand the whole page. We just need to know where to jump into the page to get the data we want. So HTML is hypertext markup language, and it's the standard out there for creating web pages. So whatever browser you're using is interpreting HTML tags to render the web pages you see. And all HTML tags have angle brackets, and typically most of them come in pairs. What do I mean by that? This is very, very basic HTML for a complete web page. What you see here is, just as a string, I have an HTML tag. This is the basic root of the whole tree. And then you have the head part. See, opening and closing angular brackets. This is a head tag, opening and closing. And then you have the body tag here. And in the head, normally there's metadata for search engines and things like that, and the title of the web page. And then the body is where the actual website content is in. And here's an example, just a headline test, and then P is for paragraph, hello world. And if I change this to a different headline version, you can see I can execute this, and now it's centered. So headlines are numbered. And basically, there was a chapter headline, and now it's maybe just a paragraph headline, and then the font gets smaller. So this is the way HTML works. It tells your browser, this is a very important headline. Make it bold and fat and big. And this is a paragraph that I want, that text I want to stay together. So useful text to know headlines. Because often the data you want, right, is in some table or something, and that has a headline above it. So this is a good way to find an entry point into a web page. Paragraphs, if your data is in a paragraph there. Line breaks I put in here because they're one of the few tags that I know that actually do not come in pairs. A line break is only this one tag. And then tags can have attributes. An A tag is giving you a reference. So if you want to have a link in a web page, you use this A tag, and you can see this is fairly long, right? The whole tag goes until here. And then this is the actual text, and there's the closing part. So this is how you specify a link on a web page. What you're going to see on the web page is an example link, and then most of the time that text is blue, right? And you know you can click on it, and it's going to take you to some web page. And where it is going to take you is specified in this href. And href, in this case, is an attribute of this A tag. This is basically all the HTML knowledge you need. Like, this is the level you need in order to scrape websites. So this is an example of a very simple web page. This is actually the site of the Python library I'm going to use to scrape from web pages. This is beautiful soup. And you can see, I don't know whether you guys still remember this. This is what the web used to look like in the past, right? Very simple, text rendering mostly, image at the beginning, few links, not very sophisticated. But this means that the source is not very sophisticated either. So it's nice to scrape from the site. How you can see this is in Chrome. In Chrome, there are tools, and there's this view source. If you want to have it faster, you can hit Ctrl-U. And this shows the source of the site, just to show you this is actually in there. You have the opening HTML tag, then you have the head. This is metadata for search engines and the title of the web page here. And then here comes the actual body with the content of the web page. So the good news is that browsers by now actually help you and support you in finding only the relevant bits and pieces of the web page that you're interested for. What you're looking for is a function called inspect element. I forgot what it's called in Safari. It was something similar, but you can open it in Safari with Command Option I. This should say Safari, I'm sorry. I couldn't test that because I don't have Safari. If you have Chrome, it's Ctrl-Shift-I. And what this does is, let's try for this guy, Ctrl-Shift-I. And I get this whole window here. Let me put this to the right. So maybe here's a heading. I already know that. And here now is this hourglass, looking glass, magnifier. And I can click on that, and you can see that it highlights parts of the web page. This is extremely useful when you want to scrape data from somewhere, because now I can click on it. It's going to jump directly to the relevant HTML part. You see, H2. This is my header tag here for this header. Did somebody try that option in Safari? Did it work for you? Yes?
How do you do it in Explorer?
I have a PC. So the problem is not Mac or PC. The question is which browser you're using. And I think most Mac users use Safari or Chrome. And I thought most Windows users use Chrome. I actually didn't think about the Internet Explorer. I should have this guy on here, right?
No, it works on there.
It's Command-Shift-C for Mac.
Command-Shift-C, not I.
Yeah, maybe.
Command-Option-I works in Safari.
Command-Option-I in Safari. It's not about Mac. It's about the browser you're using. If you're using Safari, it should be Command-Option-I. And if you're using Chrome, it's Control-Shift-I. And if it's Internet Explorer, it's F1 for help, and then inspect elements. So just so you know, this was the long way for Safari before I found the shortcut. Just so you know, like HTML, I thought can be fairly scary, just because web pages, after a while, you don't see anything anymore. It's just all tags and plain text. So this is really, really useful because it can directly take you to where you need to be. So different useful libraries for scraping. URL-lib is very basic. You can do a lot with it already, but it's more footwork. Like you need to write a lot, and I think even specify requests yourself. Beautiful Soup is the library I'm going to use here for HTML scraping. I think last year also they used Pattern. These two, I didn't really see that one was more powerful. I think for some time there was a danger that Beautiful Soup wouldn't make it to Python version 3. So people started using Pattern more. But the community is back, so Beautiful Soup is going to be out there for Python 3, so you can really just make your choice. If the homework specify which library to use, please use that one. As I'm using Beautiful Soup now, I assume homeworks are going to use Beautiful Soup too. And then LXML, I'm not going to talk about this here. It's just even more advanced. If you have something really, really cool in mind for your project and say this is going to be such a nightmare to parse with Beautiful Soup even, it might be worth to just look at this library. So let me make that a bit more. So actual scraping. I have an URL here that is just this Beautiful Soup homepage that we saw before. So this is just a string that contains this URL. And now I'm using the URL-lib library. And this has a function URL open. And this gets the string. And then I'm just calling the read function on this. And what this is going to do is it goes to that web page and pulls the whole HTML text. And now instead of showing that in a browser, I actually have it in a variable in my Python script. And ta-da, I in principle just scrape, because all the data that is in that web page I have now in my Python script. And I can like get out of this whatever I want. The problem is it still looks like this. Right? It's just one big string that contains all the HTML stuff from the page. So what we can do basic things with this already. So we can, for example, check, is the word Alice mentioned on the Beautiful Soup homepage? Let's do that. How do I check whether a word is in a string? Alice? Now what? Yes? In? Yes? In string. What is my string? Source. Exactly. Is Alice in source? No. That was disappointing because I actually thought the picture in the upper right corner would be from Alice in Wonderland. I thought she looked like it, but maybe not. I actually haven't read the book. So then just some more string functions. This is now not only scraping. String operations are extremely useful for data wrangling later on if you need to manipulate strings. And Python has really neat ways to do this. So just a couple of options here. How many times does the word soup occur on the web page? How do I find that? Yeah, so my string is source, right? And tab completion. So I just typed source dot and then tab, and it's listing me all the different functions I can call on this string. And you can see up here, one of those functions is called count. And that sounds really useful. And remember, question mark, count question mark, and it opens your help, right? And this tells you what the count function does. Return the number of non-overlapping occurrences of substring sub in string. So this is exactly what we're looking for. So I use the function. This is why I put the brackets now in there. And what I'm looking for is the word soup. 41. I think they could have made it one more, right? So I'm going to wait now until somebody tells me the index of alien video games in their web page. And yes, it's in there. Yes? 1,695. Let's check whether that is true. Source at P220. Yes, alien video games. How did you find that? Source.find and then alien video games. Yes? Yes? So this is, I'm just going to put this in a variable that I called P for position. Maybe let's do this. So I save the index, and then a string can be accessed just like a list. So you have source, and then you have square brackets, and then from position until position plus 20. And this gives you that part of the string that is in there. Yeah, I can leave that in, actually. So Beautiful Soup, now the actual library, that was just string parsing, right? We didn't use Beautiful Soup even, and could already learn something about the web page. And Beautiful Soup is really designed to make your life easier, and has many good functions to parse that HTML structure of a web page. And here's some examples. So BS4 is how I import this. I think that is the standard also in the documentation. I try to import libraries always that I have this prefix, so you know that this function actually is in this library. So this is how you do it. You access the Beautiful Soup library, and you create an object, Beautiful Soup, and that just gets this whole string, right? Source was just this gigantic string with our HTML code. And we're going to put that into a variable called soup. And let's see what we gained. Yeah, looks like before, right? Not much. But the soup has now a function. So now soup is no longer, source was just a string, right? Soup is now a beautiful source object, which means if I hit tab now, I get a lot more in different functions. You can see there's something called contents and children and decode and something like this. And there's also one function that is called prettify. And if I print this instead of the actual only source, you can see that I get basic parsing here. So it shows that HTML is higher in the hierarchy than head, right? You can see this indentation here. So let me put that under the right comment. So it also has a function to find all tags. Find all. And the A tags, why were those useful? What is my A tag useful for? Yes? Yes, those are the links on the web page, right? A is the HTML tag for finding a link. So let's see what this does. Let's actually not do this. Let's do this. You see here I got a list, right? It's a square bracket that opens here. And there's already my first A tag. And then there's the comma, and the next element is again an A tag. So I now just got a list that contains all the links that are listed in this whole web page. It cost me 1 line of code. So why? I'm just going to uncomment this. If I do this, I get an empty list. Why? It's the same function. It's soup.findall. And I just, again, wanted to count how many occurrences of soup are in the web page. Why does this not work? Yes, it's not a tag. So findall really expects you to specify tags. Soup is not a tag. So we can do soup find A. This is now just giving me the first link in this whole web page. But maybe I actually don't care about the tag. I want that attribute. I want the actual link in there. And I know this is href. So I can say tag punkt dot. I can't. Oh, my tab completion is not working. Because I didn't execute. So I actually forgot the name of the function now. Great. Ah, get. Get sounds promising, right? Yes. So you see, this tab completion is really, really useful, and I need it too. So I found the first occurrence of A in the web page, and then this is how you get the attribute, right? I saved this tag here in this variable tag, and then I could call get to get the actual attribute. And this is giving me the link that this A tag specified. So there's also a getAll function, right? So how do I do this? I want all links in the page. Soup dot. Yeah? Yes, we even had this, right? So just so you know, I'm going to put this online afterwards, right? So you do not need to like type like crazy and try to keep up. But if you want to follow along, that's fine. So Findall A is now in my links. And now I can have a look at this links list. And what you're going to see is, yes, they're all H tags, A. And now I want all these actual links out there. How do I compile this in a list? What I can do is a list comprehension here, right? So we've seen up here, get href is how I get the actual link. And this is now a Python thing for me. At least I didn't know this before, and from another language. So these are list comprehensions. What you can do is you say t.get href. So I'm calling this attribute. I'm getting this attribute from a variable t that I haven't specified yet. And this is going to come now for t in links. So for every tag in my link list, I'm going to call this. And what you see here is now I have a list, right? This is in square brackets. I have a list that only includes the links. So in principle, you could do this with a for loop, right? For t in links. So this is how this would look like in long. For t in links, right? And then I would need it to do something like L is an empty list, and then I can do L dot append t dot get href, right? This is how I would have done it the old way. Like you have a for loop over all your links. This is the list, right? So t in this for loop is going to go over all the different entries in the list. And then you call this get href on this t, right? And t is just your variable in the for loop. And you put this together in a list. And this is kind of doing the same, just compiling it into one line. And nearly all programmers don't like to type. So this should really do the same thing. Let's try. Print L. Oh no. Just do this. Yeah. So L now is again the same, right? I have my list here. Oops. So you can also pass the tree instead. This is really all I'm going to say about how to get tags out of. Interesting. This is all I'm going to say about how to filter tags from an HTML page. Do you have questions right now about this? I'm just going to do some more tree parsing, and then we're done with that part. Yes?
Can you do the inward to filter the external length?
The external length?
One says,
Oh, right. I can say, oh, interesting. I think the easiest is just to check that it starts with, doesn't, so this is an anchor here for a link to something else in the same web page. And this is something on that same web page, and this is something on really external web page. So if I say I really only want to have this, you can say I need that string to start with HTTP, right? This is something you can filter for. If you do this in the long version, you can say link is here. I'm going to copy this out. So now I saved the actual link here. And now only if for, not sure whether this works. Let's try. Nope. Ah, yeah, that was stupid. Append link. Starts with, thank you, because I didn't know about it. How does it work? This is a function of link. Yeah? This doesn't work. Yeah, let's try. So do you know how it's written? Because my type completion doesn't work yet. Starts with directly just this HTTP. Yay, cool, thanks. So only then I want to append link.
Is it camel fit?
Hmm?
Is it camel fit? Capital W.
Capital? Why? It's a function. Shouldn't. So let me try link as, I can actually cheat. I'm going to do this now. Oh, I actually did it that way. It worked. Ah. Did this before. Let's try this. That is meant to be there. Over this one? Yeah, because this is the actual element that is in my list afterwards. It's like here. This is the element that should actually end up in the list. So it's I for I in links. Links is my link list, right? Ah. I'm going to skip over this soon because it's taking time at the moment, but I'm going to update then. Yeah, ha! Okay. I need to cheat. So the reason I need this I here is because the list comprehension needs to know which elements actually to list. So this is the I, and then this is the for loop that actually filters them out. So I goes over every link in the link list. That was my problem before, right? So this is now the actual strings with the links already. I tried to filter links up here before, and this is still the tags. So, and if I is not none, and that was most probably the error before, like if some of those elements are none, you're in trouble, because then it is not a string. So if I would be none, then this actually doesn't make sense. So I want I to be not none, and then the first 4 letters should be HTTP. And these are examples for data wrangling. Like this is stuff you have to deal with when you download your data from the web somewhere and it's not nicely prepared for you for the homeworks. And now you can see, now we got an actual list where only the HTTPS links are inside. So I'm actually thinking I should not do this. It's unlikely that you're actually gonna need it. I'm just gonna skim over this. So there's another option to parse a web page, and that is basically from the hierarchy, right? We had this doc string, and you had the HTML tag, and the head, and the body, right? And it's like there's one hierarchy, like the root node is HTML, and then head and body are on the same level. And then you can do things like the sibling of head is body, because they're on the same level. And if inside of body I have a headline, that is a child of that body tag. So this is another option that Beautiful Soup provides you with to parse a web page. But I'm going to skip over this now. Yeah, I'm also only going to go shortly over this because I want to come to the singular value decomposition still in the end. So this is just a cool scraping example from Catherine that I found online. And what she does is she specifies a list of the stuff she likes. And then here are empty lists initialized, the happy hours found, because we haven't found any yet, and the happy hours then that are actually for her personalized. And this is the URL from the LA webpage. And this is what we did before, just using URL-lib to open that web page and read the whole content into one string called source. And then she calls it tables. This is your Beautiful Soup object. So just normal initialization as we had it before. And this is this find all from Beautiful Soup, right? So you have all your data here in tables, and you have the for loop that goes over all p tags. P were paragraphs, right? And this is a version where you can directly request that this paragraph has an attribute called class calendar event title. This is just, if you look at the LA web page, this is where you can find the information always about the happy hours. And then she compiles the text inside of this into a variable. And this is this tree parsing, right? T.find next siblings. So it's in that hierarchy, the happy hours are listed just one after the other. So they're all in the same hierarchy level, so they're siblings of each other. And this then can just be appended. And so these are all the happy hours found then. So the scraper found 66 happy hours, and these are all now saved in this found happy hours list. And now she's going over the stuff I like list that she specified before. So food is just going to be that food that she likes. And in this list of found happy hours is the HH variable. And now she makes sure that she doesn't have any duplicates and that this happy hour actually contains the food she likes. So if the food is in the happy hour tags and happy hour is not already listed in my happy hours, then yay, I found some, and you append that one. So out of those 66 happy hours that were found, she actually only needs to look at 4. This makes life a lot simpler, easier, and faster. And here she actually compiles a message for herself that I think she even shows in her talk, if you want to look at it, how to send yourself this then via Gmail. So you can have such a script that goes out there, parses your favorite web pages, compiles all the information, and gets it to you. This is now live scraped, so that just happened. Okay, let's at least do the Rotten Tomatoes quickly because I want to show you how to use an API, and then we're going to do the SVD. So Rotten Tomatoes, I think everybody knows their webpage, right? Who knows Rotten Tomatoes? Yeah, the others more look like they just didn't listen to the question. So the Rotten Tomatoes webpage just has movie ratings out there. And they're one of the pages that expect you to want their data, so they provide an API that is fairly simple to use. You saw the registration was also quite simple. So this is a case where we need an API key. And the whole idea behind API keys is that they identify you, right? So if you try to overload their servers, maybe it's just a bug in your script or something, they know who is that guy that just shut our servers down, or at least tried to. So be careful, your name is attached to everything you do when you use an API key. So you can register here. We already did that in the beginning. And I was a bit in a conflict because I wanted to show you that stuff. On the other hand, I don't want to paste my API key in here, right? Because this video goes online. I maybe wouldn't have bothered about you guys, but this is going to be world viewable from our webpage. So what I did is I have a secret file here that gives me functions. And these just return the keys for me, so I don't put them in the IPython notebook. This means for you, when you execute these notebooks at home, they're going to throw an error because you don't have the secret file, because it's secret. And what you're going to do is, when you register for Rotten Tomatoes, this is the place where you put your key. Just literally in strings. So you really just go, my key. So this is the API key, and then the URL and our usual read in. Yeah. So what you're going to see is if we print that data. Did anybody successfully register and is able to follow along? Yes, question? Good point. I'm actually not using it here, am I? Not sure. Maybe I changed my mind at some point. Maybe that was from somewhere. I don't think I need this here. So the data that I got is a big thing of nothing, and then here it starts. And for Python novices, this is weird because this starts with these curly brackets. Are they called curly brackets? So this is a dictionary, and more specifically, this is a JSON encoding of a dictionary. So let's shortly check what that means. So dictionaries are a built-in data type in Python, and they work with key-value pairs. Yes? Oh, where did I actually use the key? Interesting. Yeah, sorry, it's not visible here. Yeah. So what I do is the whole URL is specified here, and then here it says API key. So I append that API key to the URL, and then it's going to download the data for you. So Python dictionaries. Dictionaries are a built-in data type, and this is what they look like. So you have these curly brackets, and then you have keys, and then their values. So it's not just a list where you would say first element, second element, third element, but you have keys so you can directly jump to the values you want. So if I print A, I just get the whole dictionary. I also can get the keys of A, like this. It has this key function, and now it's listing in a list now, right, square brackets, A, B. So these are the keys up here. And what I can do now that I know what a key what keys are in there, I can, for example, access A, or maybe make it less confusing, A on the key B. This should give me a 2, right? A is my dictionary. I'm asking for the value for key B, which is specified up here. Yes, I get a 2. You can also just directly ask for all values. So there's this value function, and this is just giving you all the values that are in there in this whole dictionary, one after the other. I'm going to do maybe all of these examples. So there are different ways you can loop over a dictionary. You can use the zipped version for key value in zip a.keys, a.values, print k, comma v. What this does, this zip here puts me together, so a.keys was my list with the keys, right? And a.values is the list with all the values in the dictionary. And I want a for loop that goes over 2 variables, k and v, and k should go over all the keys, and v should go over all the values. You can do that with a nested loop, maybe, but this is directly just taking one key and one value pair, right? Assigning it to k and v, go the next step, go the next step, go the next step. So you see A1, B2. I think this most probably is for Python novices the most useful information here. There's an internal way too. I'm just going to uncomment this to leave this in for later if somebody wants to look it up. KV in a.iter items. This implicitly does the same, just a neat function to do the same. This is more general though, because in principle the zip you can use with any lists out there. These do not have to be dictionary lists. So whenever you want 2 variables iterating over 2 different lists, right, in parallel, you can just use the zip command. If you already know your 2 lists are the keys and values of a dictionary, you have this convenience function, iter items. So now we know what a dictionary is. What is JSON about? JSON originally has nothing to do with Python. JSON is JavaScript object notation, and it's a general format to exchange attribute value pairs between servers, between humans almost and servers. And the nice part is it's human readable. What that means is if I have my dictionary here, and I'm going to here call this JSON library and dump the string that represents this dictionary into S. Let's look what S looks like. So it's almost the same, right? All that changed is I have here now the double quotes. This is because print already omits part of what is in there, right? Print already expects a string, so it omitted these guys here. Do you see the difference? S is a string now. A is just a dictionary, right? No quotes here. If I output S, this is an actual string. I can do things like A in S. And I get true, because S is a string. And then A2 just parses this back. And this is looking a bit funny, right? But it's actually nothing else than A in the beginning. This is also just a dictionary with the key A and the key B. And this U here, does anybody know what that means? Yes, it means that this is Unicode encoded. And I normally just don't bother and leave them in there. I'm getting really low on time. images there. So I'm just going to do a quick thing. So this data dict now is a dictionary, right? And you see that this now contains the data we scraped from the web page. So data was what we got with our read command, right? With url-lib, that is our whole string thing. And now I parsed this with the JSON library to actually be a dictionary. And you see here the dictionary, right? Curly bracket in the beginning. So we can look at the keys of this object. And you see here movies, templates, link templates, and links. So what we're interested here is movies. So the movies are data dictionary at the key movies. This is how you access a dictionary. You give it the key, right? I'm asking for the value that corresponds to the key movies. And you can see here it's a list now. And it's again a list of dictionaries. And most probably each of these dictionaries now is going to represent one movie. So I can test that. Test is movies at 0. Give me test. Test is a dictionary. Again, look into the keys. So this is how you explore data when you get it from a web page, right? It's going to be one large JSON string. You pass this into a dictionary, and then it's really just looking what is in there. Keys function, show me what different options are in there. What can I do with this data maybe? So you see a single movie here has ratings and links and a title. Rating sounds interesting. So let's say test ratings. And you can see each movie has different ratings. So let's say, and this is again just a dictionary here with an audience ratings and a critics rating. So this is here, now we found the critic score. It's here. So ratings at critics score. This is the actual score from the critics. So you can dig down this whole hierarchy. Yes? You can do dictionary, dictionary, dictionary. It's just gonna, like for me, it doesn't work in the IPython notebook with the tab completion then. This is a weird thing here, but you should be able to do, let's try, test ratings. Like this, right? This is what you wanted? Yeah, and it's the same. Score, let's try really, and then make sure it's this guy, yeah. Okay, I'm gonna leave that quiz up to you, or you can look it up in the more complete version later. That was a bit more about pandas data frames, and I'm going to skip over the Twitter example. The Twitter API is really just using another external library. So it's not about JSON and dictionaries necessarily, but there are libraries out there for the more elaborate APIs that can make your life easier. We're going to come back to this later when we need Twitter data, because I really still want to do this. Just complete cut. No more data scraping now. Do we have final questions about data scraping? No. Okay. Singular value decomposition. Maybe you remember last week, Raphael showed this cool genome data set, right, where they did the study, and he showed a projection of that genome data into 2 dimensions. Do you remember? I think Here, this was the singular value decomposition that he showed, right? It was a bit like magic. He had this, he said, your data matrix is explained by 3 different matrices. Then somehow you only use parts of these matrices, and you try to compress your data that way, and you get a multi-dimensional scaling plot, right? So these are all these genome data projected down to 2 dimensions. So here's how you actually can do it in Python. So I'm using this library SciPy that came with Anaconda when you installed that one. And this is a part here that you do not necessarily need to do. I'm doing it for my sanity when I give a lecture. This is seeding the random number generator. This makes sure the numbers are still random, but it's always the same number now when I hit Shift-Enter. So we make some data up. This is just generating a point cloud here. So there's a function in the NumPy library that generates multivariate normal distributed data points. If you don't understand this completely, that is totally fine. This is just for me to have illustrations to show you how the singular value decomposition works. And I could have read these points from a file. I just generated them because it's quicker. So here's a plot of the points we got. So it's a point cloud in 2D, and you can see there's a correlation here. So that is my x-axis and my y-axis, and these points only are in 2D. So this is all the data we have at the moment. And this is just the normal scatter plot, and equal makes sure that you should have equal distances here, I think. So this is a way to create a matrix here. So x and y, I had 2 different column datas that I generated with my function before. I didn't have one data matrix. I had one x column and one y column. I need those together in one matrix in NumPy, and this is what I do here. Column stack is just gluing those 2 together into one matrix that I need here. And this is the function that does all the magic for you. So the SciPy library has a linear algebra part, and that has an SVD function. And all you need to do is plug your data matrix in here, and you're going to get those 3D matrices out, right? Your U, S, and VH. And the way it's going to look, I'm printing S here. S has only 2 values. Let's do U.shape, S.shape, VH.shape. So my matrix was 500 data points with only 2 dimensions. And you see U here is 500 times 500. Then S, normally, when you see singular value decomposition described, should be a square matrix also that has diagonal elements. You see this one has only 2 elements. These are the elements that are supposed to go into that diagonal. We're going to do this by hand. And then the VH is a 2x2 matrix. So what I need to do now is, and I already get a function for this from this library because people need it all the time. At the moment, I only have 2 values in S, but I need this diagonal structured matrix, and there's a function for that. So you just call this diag SVD S. You tell it 500 is the number of data points I have, and 2 is the number of dimensions, right? So this is the dimension my data space lived in. And what you can see now is before, S looked like this. It's an array with just 2 numbers. And now uppercase S looks like this. And you can see it's mostly zeros, right? But in the first 2 diagonal entries, this is where the values of S now went. This is all this function did. It's just convenience for you. And now, this theorem and the whole singular value decomposition says you can create these 3 matrices such that if you multiply them, it regenerates your original data. That's what it's all about. It's a different representation of your data matrix split into 3 different matrices. So what you see here, this is the sanity test I actually just multiply this 3 again, these 3 matrices, and this is the reconstruction. And if you look at this reconstruction here, matrix at 1, right? Here, this is the other one, and you actually don't really see a difference. There are numerical instabilities, so they might be not entirely equal. Maybe e to the power minus 17 or something, like way, way, way beyond that dot, there are different digits. So NumPy has this function all close. This tests whether the reconstruction here and the matrix are close together. Not necessarily equal, there's a small epsilon allowed that they can deviate. So I just wanted to convey at least a bit of the meaning. I think we're going to have more about PCA later on. And I think Raphael is maybe also going to do more about this on Thursday. I don't know. Just to give a slight intuition what this is about and why it's not magic. So this is the point cloud we had in the beginning. And what I do here is I visualize the column vectors of that matrix VH. That was the third one of those 3 matrices. That was just 2 by 2. So it's 2 vectors in a 2-dimensional space. And I can just draw them in here. And what you see is they're orthogonal to each other. And one of them points into the direction of this variance here in my point cloud. And this is the other direction with the main variance that is orthogonal to this one. What it does is it really finds the direction with the greatest variance in the data to explain it. So now we actually want to project that data down, and I needed to execute the cell before, and I didn't. So these are 2 ways to actually project the data down now. The data is living in just 2 dimensions, and we want to project it onto 1 dimension. And there are 2 different ways you can do this, and you can see they're all close here. Projection, projection 2, it's giving the same result. So you can either just multiply that U matrix, right, USV, were the 3 matrices that came out, with only the first component of this S matrix, or you can take the original data and multiply it with V, and also there only the first column. Right? So V was 2 by 2, and my original data was 500 by 2. So normally, that doesn't do much, right? It gives me a 500 by 2 matrix, normally. If I only take the first column vector of V, I have 500 times 2 multiplied with 2 by 1. So this gives me a 500 times 1 vector of my data. So it's encoding all my data points that were 2-dimensional now in 1 dimension. And this is a visualization of this. So you have here your actual point cloud from the beginning, right? So the scatter plot, x, y. And then I plot the projected data points here. And I just created a 0 vector for the 2nd dimension. So they're all in 1 dimension, really. And now here you see lines that show the relation. So this point here was projected onto this position, and this point here onto this position. So what you can see here is it all gets rotated, right? So this line here is really along the main axis of this data cloud. It's preserving the main variance. And I think this gets a bit clearer if you actually project the data back. So what I did here is I reconstructed the data. So I compressed it down to this 1 dimension, threw everything else away, right? I only know about this data, what is left in this 1 dimension. And then I try to project it back as good as I can to the 2D space. And then you can see now that they really align with this point cloud here. And now the original data points are all, these lines here are all orthogonal, right, to this guy. So these matrices really specify rotations in that space. And the vectors of V somehow encode this nice basis that you can use to project your data points. The main part about this, though, is for you guys, for the homeworks, to know about these two functions in the very beginning. Here is your singular value decomposition. This is how you create this diagonal matrix. And then a few cells later, it shows you how to project it down to one dimension. Yes? It is PCA. Basically, yeah. The USV, my problem is that I can't really throw around with eigenvalues and things like that. But for those who understand, the entries in S actually are the square roots of the eigenvalues, right? And the columns in V are your eigenvectors of the covariance matrix of the data points. This is PCA.